What is up, guys, and welcome back to the channel Cloud Space with Siba. Today we're looking at a very exciting topic, which is GitOps and how to specifically design a GitOps workflow. If you're involved in software development or operations, I think GitOps is going to be a game changer for you. It has been for me. And the reason for that is because it really streamlines the deployment process and enables collaboration really with a lot of teams. And in doing so, it really drives a lot of benefits to the modern development practices that we have today. But before we dive in, if you're new to the channel, please don't forget to subscribe to Cloud Space with Siba for more insightful content around AWS, serverless, and Kubernetes. All right. Now, in this video, we're only going to be talking about really what GitOps is and the design. And in another video that I'll also be releasing this week, we'll look at how to actually implement a GitOps workflow from scratch. Now, before we get ahead of ourselves, what is GitOps? In simple terms, GitOps is a set of best practices for managing and deploying infrastructure and applications using Git as a single source of truth. It's a declarative and automated approach that revolutionizes the way we handle deployments. Now, key things there: declarative and automated. It means that our infrastructure and how our applications are configured are declarative, meaning that they're actually written out as YAML files that we store in Git, which itself acts as a single source of truth. Now, that declarative way of doing our configuration actually represents the state or the desired state that we want for our infrastructure and our applications. Those declarative files are then taken into an environment to then spin up the kind of environments or applications that we want to run. Now, the question is, why GitOps, you might ask? GitOps is very important and key because if you look at the traditional deployment methods, those often come with a lot of challenges. Namely, it could be things like lack of versioning, collaboration issues, and manual interventions. You want to get something into production, you're going to do it manually. However, GitOps addresses these pain points by bringing version control, collaboration, and automation to the forefront of our deployment process. Now, let's break down the key components of a GitOps workflow. Firstly, it's declarative configuration. In GitOps, we express our infrastructure and application configuration declaratively in a version controlled repository. And you'll look at, when we actually get into the design, you'll notice how there is going to be source control for the application code itself, and there's going to be a repository for the configuration or declarative files. Now, what this simply means at the end of the day is that we state what we desire in those files, rather than a prescribed set of steps on how to actually build our environment. Now, version control is crucial. Git becomes a single source of truth, and it provides the versioning, the history, and the collaborative features that we need. Everything from infrastructure code to application manifest is stored in a Git repository. Now, version control being one part of GitOps, the second part is automation. Automation is the heartbeat of GitOps. We leverage CI/CD pipelines to automate deployments, and you'll see again in the design how this comes into play. And the reason for that is because it ensures that changes that we make and are in our Git repository actually trigger an automated testing and deployment process, right? So that being said, in terms of what the definition of GitOps is and some of its core components, I want to run you through a simple design of a GitOps workflow. If you look at the image here, which you have been seeing, you'll notice that. All right, so in this workflow here, now I do take into consideration the fact that I use AWS services, but there are equivalents out there for each of these, and I'll make examples of that as we go forward. But the idea of GitOps is that we have our developers who are writing the application, right? They're adding features, they're writing their tests, and every time they complete their work, they then check in their application code into Git. Right. This is where things like code review will happen. Pull requests are then created in order to merge the code into into the rest of the application, right? So, but what then happens is that what kicks off our GitOps process is that when that code is checked in, we then have a pipeline that runs. And this pipeline has three main purposes. One, it is to build the application. Second, it is to test the application. And third, it is to package the application. In the build step, what we're doing really is we're installing all of the packages that are required for the application. Once that is done, in our design, we'll have a test phase, right? In the test phase, as you can imagine, we're running all of the unit tests that the developers would have written for testing specific business requirements. Anytime those tests fail, our developers are made aware. Anytime those tests pass, then we move on to the package or the packaging step. Now, the packaging step is very crucial because it is in this step that we build a Docker image. And the Docker image is what's going to be a representation of running that application in orchestration systems like Kubernetes, or mainly Kubernetes, really. I almost said including ECS, but not really, because this workflow is designed really to deploy our application, the desired state of our application into Kubernetes. Now, once we package the Docker image, we need a repository in which we store it in. Now, there's countless examples. I have ECS here, which is an Amazon offering of what Docker Hub offers. ECR is Elastic Container Registry, and so what happened is that our pipeline will then push that into ECR. Now, when that is pushed into ECR as part of our design here, we then have a second repository. Now, it is best practice to usually have a separation between the application code itself and the configuration manifest files. And so what that happens is that we need a way, we'll design a way where when the image is pushed in, we then have a way to update we'll have a way to update the image itself on the configuration files. Now, this is important because then what happens is that when that change happens, it kicks off another process within our cluster that then is paying attention to these changes. Now, the tool we have in our design is Argo CD. There's many other tools out there, for example, Flux, but Argo CD is what I've chosen with this particular design. And so what Argo CD does is that it sits within the cluster, and what it does is that it's paying attention to any changes that are happening within the configuration files themselves. And anytime a change happens, it does a poll and pulls in the latest YAML files, which obviously represent our desired state. It then deploys those YAML files into what is known as our EKS cluster over here, which is essentially managed Kubernetes. And we'll deploy that either into any namespace that we want. So, for example, we could have a prod namespace or a dev namespace. In the dev namespace, it'll automatically deploy into the dev namespace, but for production, once the dev testing has happened, the application is working as expected, then we can have a manual process that deploys into the prod namespace. Now, this is a simple design, but takes into consideration the whole entire flow. And the whole reason really we want to do this is because we're trying to avoid a situation where we are deploying straight into our cluster imperatively. And the reason for that is because imperative deployments like this are things we're not able to really track. We can't say who did what changes were made and when, and especially we don't know why. But with the GitOps design like this, we're able to track the whole flow. We can know what features were deployed, were checked in by the developers, and we know therefore what application code images will have based on those commits. At the same time, we also know declaratively what the state of our application looks like, simply because all of that is stored in Git. And this is very important, right? Because it represents what our application should be. And anytime there would be, for example, a disaster, would then be able to simply deploy our application into a new cluster if we need to do that, right? Now that's it's a far-fetched example, but it represents a situation where we would easily bring up our application, right? So this is our GitOps workflow design. I hope this gave you insights into what GitOps is, and at the same time, what a GitOps design looks like. I hope you found value in the video. For any comments, please don't hesitate to share those. Any questions, also please ask in the comment section. And if there's any particular part of this that you want me to go deeper in, just let me know and I'll ensure that I do a video on that. All right, so thank you so much for watching. I really appreciate your time. Please don't forget to subscribe. Please don't forget to hit the notification bell so that you're aware when I upload videos, especially the fact that I'll be uploading a video on how we implement this from scratch. Thank you so much for watching, and I'll catch you in the next video.